final project is about age group classification. Through this presentation, we're going to introduce a general idea, the significance, and implementation of the age group classifier we develop. Age group classification is a really complex but a crucial task that is used to classify facial images into predetermined age categories. It is an important task due to its numerous applications such as health, security, authentication system, recruitment, and intelligent social robots. As shown in this GIF, the real-time age group classification on webcam video is just one of the applications of age group classifier. Since convolutional neural network has shown extraordinary performance in terms of analyzing facial images, it is widely used in the state-of-art models. For the purpose of this project, we implement and fine-tune an age group classifier to perform a task of age estimation based on a still image containing a human face. To train our age group classifier, we will rely on the UTK face dataset and the facial age dataset. Specifically, the UTK face dataset contains around 24,000 RGB facial images, and the facial age dataset contains around 10,000 RGB facial images. Since both datasets already provide a clean frontal facial images standardized to 200 x 200 pixel size, we decided to merge the two datasets together for this project. Then, we pre-processed the combined dataset and resized images to 98 x 98 pixel size to speed up the training process. It is also worth mentioning that we converted all training images in the combined dataset from RGB to gray to improve the classification accuracy. Last but not least, we chose to augment the training image samples in the combined dataset to increase the amount of data for the model to train with. It will be extremely useful to increase the variance in the dataset to improve the model's accuracy while decreasing the probability of overfitting. In this case, as shown in the illustration, for every original image, 9 other augmented images were created by flipping the images and rotating them by various degrees. As a result, the augmented training dataset had a total of around 336,000 images. For this project, we adopt the CNN architecture from the baseline model and fine-tune its structure throughout the semester. Specifically, the input is a gray image with 98 x 98 pixel size. Then the image goes through 4 convolutional blocks that consist of convolutional layer and average pooling layer with the use of ReLU activation function. Eventually, it will reach the last dense layer, where the age group label corresponding to the greatest possibility will be the predicted age group. During the training process, we use categorical cross-entropy as the loss function, and use Atom optimizer with a changing learning rate that is dynamic with the current epoch. Specifically, the initial learning rate is 0.008 and will be half every 5 epochs. Just as shown in the figure, both training and the validation accuracy have a strong upward trend. To elaborate on that, the training accuracy gradually increases from around 30% to around 90% after 60 epochs. The validation accuracy starts around 35% and ends up reaching approximately 70%, which is not too bad. For evaluation, we mainly use F1 score and accuracy to quantify the performance of the age group classifier we develop. Based on the method introduced in the previous slide, the latest model we developed can achieve an F1 score of 0.7042 and accuracy of 0.7034 with a categorical cross-entropy loss of around 1.5. Just as shown in the confusion matrix, the majority of the classification mistakes are contributed by the testing facial images from age group 3 and 4. Even though we do have more training samples from age group 3 and 4, it did not lead to higher classification accuracy as expected. Classifying the facial images from age group 3 and 4 is an extremely challenging task since the facial features of adults from 21 years old to 45 years old tend to be unchanged, and are not easily distinguishable even by human eyes in some cases, as demonstrated by its literature review. However, since the model we developed has done a great job classifying children from 1 year old to 9 years old, its application can be promising in terms of helping the local police investigate the crime of child abduction.